Okay, so let's go ahead and do some series circuit calculations. A series circuit is when you have multiple components that are kind of in one line, kind of like that. So this is a series circuit. A parallel circuit, you would have them, or you would have a component kind of like tied to another component like this, where both ends are connected together, and then they go to the battery. But this is a series circuit that I have here. And so this could be like representing 3 lights attached to a 20-volt battery. And some things you need to know about a series circuit is every time you add a resistor to a series circuit, it adds resistance to the circuit. And so there's a couple special things about series circuits. One is it has for the total resistance, R sub T, the T stands for total resistance of the circuit, you just add up all the individual resistance. So for this particular circuit, we would add up 1 from R1, 3, and 1. So 1 plus 3 plus 1 equals 5. 5 ohms. Okay? And so now, oopsie, 5 ohms, and let me just erase that, and that. Okay. The next thing you need to know about series circuits is that when you have everything in a series like this, the current stays the same. If you imagine if you had flow going through here like this, you can't have more flow over here than here, and they all have to be the same. Just like if you had a hose, and in the hose you had a kink, it would limit the flow in all the hose. You wouldn't be able to have more flow in one section than the other. So the current, which is the flow of electrons, stays the same. So that means whatever current is coming around here is the same all the way around. Okay, so now if we go back to our Ohm's law equation, which is V equals IR, we can use this equation locally or for the whole system. And right now we're going to use it for the whole system. So we can say the total voltage is equal to the current times the total resistance. And for this particular circuit, the total voltage is 20. Now we're trying to solve for the current. As you can see, that's our next thing here on the list. We're trying to solve for the current. So here we have current. And then the total resistance, we just calculated. It's right up here. It's our 5 ohms. So we have 20 is equal to I times 5. So now if we want to calculate this out, to get I by itself, you divide each side by 5. You have to do the same thing on both sides. And see the 5 and the 5 cancel over here. So then you're left with I is equal to 20 over 5. And 20 divided by 5 is 4. And the units for current are amps. So here we can say 4A. Okay? So now I'm going to erase this down here to make room for our next thing. So now it's asking for V1 right here. So now that we've looked at the current, now we know that the current, we already said that the current is the same everywhere. And what that means is that there's going to be, like the electrons flowing through here, there's going to be 4 amps running through there. And there'll be 4 amps running through here. And then when it gets up to here, there'll be 4 amps. So every one of this, there's 4 amps. So if we wanted to look locally, just at this resistor, and we wanted to know, hey, how much voltage is this resistor using? We could look at that, and we could again use our equation, change colors again. We can use our famous V equals IR, but now instead of for the whole system, we're going to be using it locally. So we can say, oh, well, I want to know V1. So V1 is going to be I times R1. So now if I just plug things in, I have I and I have R1. So I plug in I, which is 4, and R1 is 1. So we say V1 is equal to 4 times 1, which is 4. And then what's the units for volts? 4 volts. There we go. Okay, now we're looking for V2. We do that the exact same way as we did for V1. This doesn't really look like it. Let me see. This doesn't look so much like, that's not very neat, so I'm going to change that and write it again. One minute. So then here we look at this and we say, okay, V2 is equal to I times R2. Our I is 4, our R2 is 3. So 4 times 3 is 12 volts. And last but not least, we look at V3. So here we can say this is 12 volts. Excuse me. And now we're looking at V3, which is this one right here. And we do the same thing. We say V3 is equal to I times R3. I is 4, R3 is 1. So this is 4 volts. 4 volts. So now if we look at our voltage, here, or V1, V2, and V3, if we add them up, 4 plus 12 plus 12 equals 20 volts, which is the same as the battery over here. So you can see that the 3 resistors are splitting up the voltage, and the bigger resistors eat up more of the voltage than the littler resistors. All right, I hope that helps. And we're going to give you one just to practice. So let's just do that real quick. We'll do a quick practice run. There we go. Let's erase all this. Okay. I think I got everything. Oh yeah, let's change that. And we'll change these values. So let's make this, I'll give you a different one. Here's 2 ohms. We'll have this be 1 ohm. And we'll have this be 4 ohms. Okay, so we have R1, R2, and R3. And the the voltage, excuse me, is going to be 42 volts. So now pause this video and try to solve it. Okay, so now I'm going to go through and you can check your answers. So we start off with RT. The total resistance is just adding the individuals up. So here we have 4 plus 1 is 5. 5 plus 2 is 7. So the total RT is going to be 7 ohms. Next, we're going to solve for the current. And remember, we can do that for the whole system. We know that the total resistance, that's what the T stands for, is 7 ohms. And we know that the total voltage is 42. So now we can say, okay, VT is equal to the current times the total resistance. So we have 42 is equal to I times 7. We divide both sides by 7, and we end up getting I is equal to 6 amps. Okay, so now what we're going to do is now we know that the current all the way around is 6 amps, which means that if we zoom in, that the current here is 6 amps, the current here is 6 amps, and the current here is 6 amps. So now when we're trying to solve for V1, we can go and look locally here, because that's our R1. So we can say, okay, V1 is equal to I times R1. Our I is 6. Our R1 is 4. 6 times 4 is 24, and the units are volts. 24 volts. V2, we have V2 is equal to I times R2. That's 6 times 1, which is 6 volts. And V3, we have V3 is equal to I times R3, which is 6 times 2, which would be 12. So this is 12 volts. So now if we add this up, 24 plus 6 is 30. 30 plus 12 is 42. That's 42 volts, which matches this. All right, thank you.